we're going to demonstrate how you can calibrate a set of recorded data provided you have the raw data files available to you. So initially we start the program, we go to Files, Calibration, and we would reset just so we're starting with 0 values, and save calibration. The file is saved to a file called Calibration. Any file with this name will be read every time the program starts, and the values in it will be used. You can save files with other names, but they will just store the data, they won't load it automatically. So we save the default values of 0. We then load a data file, and the file IMU is the raw data that was recorded. We take this raw data and extract the separate maneuvers from it as required. So we accept that. We then see the display of the data on the screen. So we can then go to initially pitch roll chart. This shows us the pitch and roll angles of the vehicle. This was a straight braking profile, so there's not too much variation. This run includes a stationary portion at the start of the run, followed by the manoeuvre. So if we go to the start of the run and highlight some point, we notice these lines are virtually horizontal, and that shows us this is a point where the vehicle wasn't moving. You also notice there is an offset on each of these values, which is because the sensor box mounted on the vehicle wasn't level. So what we do is determine the offsets, and these are shown on the status bar at the bottom of the screen. So we have a 12.1 degree pitch offset, and we have a 3.6 degree roll offset. So if we close that chart and we go back to the Files Calibration menu, we can, for the roll, put in 3.6. It's negative because we're correcting, and minus 12.1. We now save that calibration file to disk. Close the calibration menu and we go back to the pitch roll chart. We now see that they're starting at 0 in the initial section of the manoeuvre, and then there's a variation as the braking profile is executed. So we've got our angles sorted. We can now go to the acceleration chart. It's a bit clearer to see how the vehicle was stationary for the first probably 9 seconds of the run. So again, we pick a point where things were horizontal, indicating a stationary vehicle, and in this case at that point from the status bar we see 0.061 as the longitudinal acceleration, 0.203 as the lateral, and 0.017 as the vertical. So we close that, we go back to the Files Calibration, and we now apply those corrections to the acceleration offset values. So 0.061 minus 0.204, 0.017. We now save these values to the calibration file. We close the calibration file and we look at the acceleration chart again, and we can now see that we're starting at the 0 point with the vehicle stationary, so we've corrected for the misalignment. And then we can see further along, this point is the acceleration away from rest, and then the acceleration decreases as speed increases, and at this point this is the maximum braking impulse, and then it drops back to a slightly lower value. So we've now calibrated the program, provided all the data was recorded with the same sensor box mounted in the same location. Then the calibration correction should be consistent for all the data files. If you move the box to a different position, you may need to recalibrate. And that's the basic operation of the calibration of the program.